All right, let's talk Algebra 2 in 3, 2, 1, 0, lift off. All right, yesterday and all this week, we've been talking about some new things. First one was we talked about the word quadratic. What does the word quadratic mean to us right now?
X squared, nothing more than x squared.
Yeah, you got an x squared, but you don't have x3s, x4s, x5s, and so on. Now, we've been talking expressions, and we're going to still talk expressions. It means that there's no equal sign, it's algebra junk, but one of those pieces of junk is an x squared piece. That's what makes it quadratic. Somewhere down the road, you're going to see quadratic equations where you've got to solve an equation that has the x squared. That's not where we're at. Now, yesterday we talked about factoring a trinomial. Now, how do you know that you're looking at a trinomial?
There's
Three pieces.
Yeah.
They're separated by plus signs or subtract signs, 3 pieces. And if it's a quadratic trinomial, one of those 3 pieces is x squared. And then one of them is x, and one of them is a number. Those are your 3 pieces. Now, we're actually going to start off with the exact one that we ended with yesterday, which was this. And it's called a perfect square trinomial. A perfect square trinomial occurs when the factored trinomial results in a pair of identical binomials. And I apologize for that sounding so seriously mathy, but we know what a trinomial, 3 pieces, and you factor it into 2 binomials, and if they're identical, then what we have looked at is a perfect square trinomial. Now let's factor this one. This is what we ended with. Remember, we need the 2 numbers that multiply to 64, yet if you added or subtracted them, somehow you get negative 16. Do you remember what they were? It was x minus 8 and x minus 8. And if you don't remember, go back one day and look at those notes.
Oh, yeah, I remember that.
Negative 8 times negative 8, Hunter, what is that?
64.
That's 64. Is negative 8 subtract 8, Joby?
That's like negative 16.
Negative 16. So then that's how we factor it. Now, if you have identical binomials, then what we can do is just write it as 1 binomial squared.
Yeah.
If you multiply the same thing twice, you're squaring it. So that even if it's an ugly binomial times itself, it's just x minus 8 squared. But because it worked out identical, this is called a perfect square trinomial because it turns into a binomial squared. That's where the square comes from. And it's special. I don't know. Somebody said it's special, so it must be special. All right, this happens. Now, there's a way to tell when it's going to happen. So it could be like a shortcut. So this is going to happen when you can take half of the middle number. So you see that negative 16 we had? If you take half of the middle number and you square it to get the third number. So I'll kind of show. If you took half of this and you made negative 8 and then you square it and you get 64, that's the pattern that you're looking for. Negative 8 squared was 64. And then it's always going to factor into whatever that half is, negative 8, like that. Kind of confusing, but we'll look at a few other examples. All right, factor this one. Now, the key here, and this is all about learning a shortcut for factoring. If you cannot see the pattern, you can always do the old school way of doing it. Find 2 numbers and multiply to 25, and they add to 10. But what I want you to see on this one is, let's go ahead and put the d's in there. There's no coefficient, so put your d's in. We're factoring this. Notice, if you halved 10, what do you get? 5. So draw this arrow and put 5 right here. And what I want you to write kind of next to that arrow is half, or half it. A perfect square trinomial comes when you half it, and then what is 5 squared? 25. Then draw the arrow going right back down to the 25 and go square it. Square it. So if I can take this, if this works out, if I can go half of it is 5 and squaring it is 25, it is special. It's a perfect square trinomial, and it's going to factor very simple. That little number I got circled is the number that goes here and here. So it's x plus 5, or not x plus 5, d plus 5, d plus 5. D plus 5, D plus 5. And this is an answer that you might see, or Or you might just see it as d plus 5 squared, just like that. Okay, let's go. Who wants to shoot this one?
Me.
I saw Justin's gonna come up
Trash
first.
can is not gonna make it.
Heck no, dude. I got this.
The trash can's full.
Let's go.
Let's go bounce
Lee, or Isaac's down. We got that trash can Isaac that's under the desk.
Yay.
I'm sure
Let me get it.
Dude, kid.
Hand it to Lee.
My shoes instantly. Lee, what the heck?
Shoot it. True.
Buckets.
Oh, fail. But you did make it on the cart, so that's something. And there we go.
Good job.
That was
Thank you for the assist.
Okay.
Lee, right, yeah. See? That's 2 questions.
Now let's look at example 2. Here we got a leading coefficient. Now this is what I said we don't, like yesterday, I said beware of the leading coefficient. Life is always easier when your trinomial doesn't have a coefficient right here. This one said if the leading coefficient and the non-variable term are both square numbers. So like 9 is a square number because it's what times what? 3 times 3. And 16 is a square number because it's what times what?
4.
It's 4 times 4. So if they're both square numbers, then the trinomial might be a unique type of perfect square trinomial. Think of this as, let's go, put 3b, and then this one, put 4. All right, this says if you multiply, here we are on here, if you multiply these two numbers and it's exactly half of the middle number, then it's a perfect square trinomial. So if we take 3 and 4 and you multiply 3 and 4, do you get half of 24?
Yes.
You get 12. So then our factored form is not 12 plus 12.
3b plus
B plus 12.
3b plus 4.
Guy,
3b plus 4.
I'm just here to learn, man.
Now, think about if it worked out to be 3b plus 4 squared. If we took 3 or 2 of these, 3b plus 4 and 3b plus 4, and we factored it out, does it work? So what's 3b times 3b?
9b.
Okay, so far so good. 3b and 4 makes, got to do it again. And then last you start with 4 and 4 makes 16. So there's your 4 pieces, and you got 9b squared plus 24b plus 16. So again, just to remember, you don't want to have to factor something that has a coefficient at the beginning. Occasionally you'll have to. But if it works out where this is 3 squared and this is 4 squared, you can take 3 and 4 and say, does 3 and 4 make half of this? If so, it's 3b plus 4 times 3b plus 4. So keep that in mind. All right, here's this one. It says if the middle piece is negative, then the factored answer should be a subtraction in the middle. This one, is 49 a square?
No.
49. There's no number I can multiply by itself and get 49? 7. So this could be, you could think of this as 7x squared. And then it's 25 squared? 5 times 5. Then the trick was to say, hey, if I took 7 and 5, what is 7 times 5? 35. Is that half of this? Yeah, it's half of 70. The only thing is, instead of putting a plus here, we're going to put a minus here. So what do you think the first part of this is? 7x. And then this one? 7x minus 5. So this one factors to 7x minus 7x and minus 5. And if you're not sure, if you're not confident, or you're doing this on a test, you can always take 7x minus 5 times 7x minus 5 and FOIL it and make sure that you get what you started with. Okay, that's this one. Let's see. Oh, Brian, from a mile away, all the way over to there.
All the way over there?
All the way over to there.
Over there? You can't throw that far.
I don't,
You
Thomas, you're supposed to.
strategically hit it off.
From a mile away.
True.
And you can hit the ceiling. Oh, that was good. That was good alley-oop. That was a good oop.
That was going in anyways.
Right.
All right, last here. Let's look at example 3. We got 49 minus 14w plus w squared. Don't attempt to factor this. Why? Not yet. What's wrong with this one compared to what you've been looking at?
Terms aren't in proper order.
It's not in order. Like what we want first is you want the squared piece first. So don't attempt to factor it until you got it in the right order. You want your w squared piece, then your w piece, then your number piece. So before factoring, before trying to worry about how to do this, understand, and the reason I put it on here is you're going to see this on your objective 103, that you'll get one that's not in order. So put it in order. So what comes first?
W squared.
W squared. Then what's next?
Minus 14W.
And last,
Plus 49.
yeah, we put a plus with that 49 because it's positive.
All right.
So if you're given this, don't try to start factoring it until you see this right here. Now, how can I check? The good thing about this one, this is a little simpler. There's no coefficient on the w, which makes life better. If I want to check to see if it's a perfect square trinomial, what should I do? By 2. Okay, so if I divide the middle by 2, that makes -7. And then what? If you square -7, what do you get? 49. So if you can half this and square it and get that, we've got a perfect square trinomial. So what goes in here?
W minus 7.
W minus 7. That number that you took when you halved it and you got -7, then you square it and it came 49, that's the magic number that goes in. And you might want to write that. Half it, square it, or at least draw the arrows. Go. -7. So that's the number. If you half it, you get -7. You square it, you get 49. That means it's special. It's W minus 7 squared. Now let's look. These next ones are, these are exactly what they'll look like when you see them right here. And let's just draw the half and square it step. All right, if this is a perfect square trinomial, I should be able to half this to what? 3, and then square it and get 9. That seems to be the case. So what should I see?
W, or A plus 3.
A plus 3 times
A plus
A plus 3. Sometimes you'll just see A plus 3 squared. Sometimes you won't see A plus 3 times A plus 3. All right, let's look at the next one. Let's say something is wrong.
They're not in order.
Not in order.
Be
So just maybe jot over here and write it in order. Y squared plus 16y plus 64. Good. Zoom out.
Yeah,
It's not in order. Write it in order. And then I have a hunch that maybe it's a perfect square trinomial.
Maybe.
How can I test that hunch?
If you can make it 16 in half and square it to 16.
What is half 16?
Like 8.
8. And usually I want to just put the 8 in a little circle. I like to do the arrow. And then if you square the 8, do you get this?
Yes.
Yeah. So what are we looking for as our answer? We got y plus 8 times y plus 8. Remember, sometimes that'll be written as y plus 8 squared. Y plus 8 times y plus 8. And lastly, tell me what kind of sucks about this problem.
It's not a perfect.
Has a
Yeah, it has a, what did Taylor you got? It has a what?
coefficient.
It has a coefficient right here, which means
I'll say it's
coefficients right here make factoring a nightmare sometimes. But is 4 a perfect square? Is 4 a square number? What is it really? 2. So you can think of this as 2k. And then 9 is, hold off on that, we're almost done here. If I take 2 and 3 and multiply them, what do I get? 6. And I want that to be half of 12, and it is. So then this works out. What goes in my parentheses?
2k minus 3
Two.
times 2k minus
2k minus 3 squared, or 2k minus 3 times 2k minus 3. Okay, and that is your perfect square trinomial for 103. All right, let's go ahead and get started. Yeah.
Hey, I got
You
my.
can shoot it.
Oh no.
Wow.
I would've made that.
Last
I got that.
one. You leave it up there?
No, shoot in this one.
This one's so full.
Shoot in this one.
Here, get past this back.
I wanna make that.
Shoot in this
Okay.
Where do you want it?
Not up there. I didn't get that choice. I just shoot it from up
Yeah,
there.
good. I want it.
You're closer.
I can't see that.
Just shoot it over Isaac's head.
A little bit right.
That would help.
Okay.
Bounce off the table and hit the
He
button.
said I do not know what to do.
I don't know. I think that was that gonna go?
I think that was going in.
I think it was gonna go. All right. Now let's go and get started. I'll put the test on there.
No, that was over the table by line.